Wonderful. We're right on time. So welcome, everybody. Thank you so much for joining today's session. Before we begin, I do want to start with the land acknowledgement. So the University of Waterloo acknowledges that much of our work takes place on the traditional territory of the neutral Anishinaabe and Haudenosaunee peoples. Our main campus is situated on the Haldimand Tract, the land granted to the Six Nations that includes 6 miles on each side of the Grand River. So once again, welcome everybody. My name is Jasmine and I work here for the WatSPEED team at the University of Waterloo. My colleague Ella from WatSPEED is also joining us on the call today. Welcome, Ella. During the info session today, if you have any technical issues or if you need to step away for a minute or if you're having trouble with your audio, feel free to message Ella or myself and we'd be happy to answer any of your questions. Joining us today, we also have Larry with us. Larry is the lead instructor for the program Data Science and will be walking us through the session along with Delina. So welcome, Larry and Delina. We're very happy to have you guys again with us. As we progress through the session today, we will be having a Q&A segment at the end. So if you have any questions that come up, feel free to put them in the chat. Or when we get to the section, feel free to unmute yourselves and you can ask your questions verbally if you would like. With that said, and without further ado, I will turn it back to Larry now.
Thank you. You advance the slide. Great. Thank you very much. Well, hello, everybody. It's a really exciting time, and I think we have some more people to admit from the waiting room. So what we're seeing is a kind of a sea change in the way that companies are thinking about how to run their business. We're seeing a change to a more scientific approach to management, the use of data, so the decisions are made based on facts, and as opposed to, like, traditionally it was much more a matter of executive opinion. Is kind of what drove what a lot of decision making was. So this kind of decision making based on fact and on analysis of data. Of course, this trend's been going on for the last 10 years or so, but we only see it gaining more and more momentum. And if we look across the industries that are being impacted by it, it's across just about every industry that there is. We're seeing, in particular, a very strong interest in financial services, are deploying data science quite widely. Telecom would be number 2, life sciences number 3 after that. But beyond that, as I say, very broad based interest in using data science-based techniques for making business decisions, as well as for the sciences and the traditional things that we used the statistical and mathematical methods for. Next slide, please. So, as I say, lots going on there, exciting time. And what I'm going to do now is turn it over to Delina, who's going to talk about machine learning and specifically some of the techniques that are used based on some of the breakthroughs that we've seen in the last few years in data science algorithms and methods.
Awesome. Thanks, Larry. Hi, everybody. I'm Delina, and I'm one of the instructors in the program at Waterloo. Outside of teaching, I'm a director of analytics at a company called Mistplay. So we regularly use a lot of the techniques that we cover in the course. But just by way of introduction, so machine learning and AI is really about trying to understand user behavior at scale and trying to automate decision-making at scale so that we can personalize products and services for different types of customers and different types of users. So if you kind of think about, if we kind of think about the history of how products and services are delivered to customers today, we really have this system of mass production where a single company might try to build a product that's applicable to as many users as possible or as many customers as possible, without the ability to truly personalize experiences because we don't really understand people at an individual level. So machine learning is really about how can we get that deeper understanding of individuals at an individual level using machines, which are going to be much faster and able to scale rather than individual humans trying to understand a broad group of people. And then how can we further use machines to help us make decisions about what kind of treatment is best for different types of customers or users? Now, machine learning in general is a subset of artificial intelligence. Artificial intelligence is a very broad term that encompasses all kinds of machines being able to execute a set of tasks. So believe it or not, even your automated Excel sheet is a version of artificial intelligence because you have implemented a set of instructions or tasks that the sheet can now complete. Now, machine learning is a subset of that, where beyond just the initial instruction of the person designing a particular model, the machine is actually able to learn on its own. So it doesn't necessarily need a teacher that explicitly prescribes instructions or prescribes how a decision should be made, but the machine can take a bit of ownership. It can use some general guidelines and start to begin to identify patterns and learn behaviors by itself. And deep learning is a subset of machine learning. And this is where we're really trying to mimic decision making, the way that humans make decisions, with more complex models like neural networks, for example, that can mimic complex decision making patterns that simpler machine learning models cannot. And let's go to the next slide. Now, there's different types, three main areas, three different types of machine learning, which is what we're primarily focused on in this certificate. First is supervised learning. Supervised learning is a type of machine learning where a machine can learn the relationships between inputs and outputs. So for example, a very simple example of this, let's say that you really like to buy ice cream and you really like to eat ice cream. There's going to be a relationship between how much ice cream you eat and the temperature outside. So typically as it gets hotter, you're probably going to consume more ice cream. So that's an example of a pattern that exists between temperature and ice cream consumption. Now, in the real world, there's a lot of different types of patterns that exist that have a much higher level of complexity. So for example, consider the decision-making process around buying a piece of clothing, right? So you might take a whole bunch of different elements into consideration or inputs into consideration. What kind of clothing do you need? What's your personal style? What budget do you have? Which store might offer the thing that you're interested in? And when you take all of these decision factors into account, you're going to create an output or a decision about what kind of clothing you need or the specific clothing that you're going to buy.
My webinar with me.
Oh, was there a question? Maybe someone needs to go on mute. Perfect, thank you. So the idea behind supervised learning is that as data scientists, we are trying to teach the machine what kind of information to take into consideration in order to predict an outcome. So let's say that we were trying to predict what kind of clothes we should carry. Maybe we have a clothing store and we're trying to figure out how many shirts should we carry or pants or jackets. And so we might think about what type of decision factors are people using in order to make a decision to buy a particular piece of clothing, and how can we use that information about a whole bunch of people to make a decision about what clothing they're likely to buy. And that's going to help us as a store manager, let's say, have the right inventory in our store. Now, unsupervised learning, on the other hand, is when we ask the machine to help us identify the pattern. So let's say that I have a clothing store and I have no idea what my customers like, right? I have no idea what clothes I should carry. And maybe so far I've just been, a store that kind of carries a little bit of everything. And what can happen from a business perspective is at the end of every season, maybe you have a whole bunch of excess inventory that can't be sold or nobody's buying. And so that becomes a loss for your business. Now, maybe I don't really know my customers that well, so I can use an unsupervised learning algorithm. I can feed a whole bunch of information into the learning algorithm that I have about my customers. So maybe I have information about their previous purchases, how often they come into the store, any feedback that they've provided me. And I can say to the machine or to the algorithm, listen, I need you to find patterns for me and let me know which of these decision points might be important for the customers. And then the machine is going to try to find similar groups of customers so that I can then try to understand, what are they interested in? What kind of products do they buy? And I can tailor my experience a little bit more to them. So that's where we use unsupervised learning, when we rely on the machine to help us make decisions. Now, the last type of machine learning is reinforcement learning. This is a really cool area, and reinforcement learning is really about the ability of machines to learn by themselves. So if you've ever seen I, Robot or any of these robot movies, or the Jetsons, if you ever watched that cartoon in the past, you know there's a lot of these home robots that can do a whole bunch of different things. This is really what reinforcement learning is the most powerful in. And that's because as a human being, let's say with the example of supervised or unsupervised learning, there's only so much we can teach the machines. So we have some idea about how the world works. We have some idea about how people make decisions. But our ideas on how people make decisions are biased based on our own experience and the experience of the people around us. Now, in reality, let's take the example of a self-driving car. I live in the suburbs, let's say, so I'm mostly faced with Toronto traffic or suburban Toronto traffic, but I haven't really driven that much in the mountains or in rural areas in different countries or areas that have different traffic laws. So I don't really have a lot of experience there. So if I was to teach a self-driving car how to interpret road signs, for example, or driving behavior, driving etiquette in a particular area or country, my experience is very limited. And if I was to design a self-driving car, all of the cars that I design are going to be really only appropriate for a suburban GTA type of life, which isn't really great because that's not scalable. Now, with reinforcement learning, we can get the machine started with some basic rules. So we can teach the machine things like, don't hit any people, don't crash into anything, don't hit any cars, don't hit any animals, drive the speed limit, try to find a number on the street that maybe represents the speed limit. And then the reinforcement learning model, based on this kind of initial set of rules, it will start to learn what is best based on the environment that it's in. So when we build self-driving cars, for example, we can put the self-driving cars in different areas of the world, different people will buy them, and each car is going to learn based on the environment that it's in, and it's going to adjust its approach based on the environment that it's in. There's some tricks with reinforcement learning. Of course, you may not know all of the constraints that you should place in the model. So, we know don't hit people, don't hit other cars, don't hit animals, but there may be other constraints that you may not think of. So that's going to be something that's a little bit tricky with reinforcement learning because it requires the creator to still think through all the possible constraints that might impact decision making. But again, this is a much more scalable type of system, which can allow adaptability of the machine to different scenarios. Okay. And let's go to the next slide. So how do we choose between unsupervised and supervised modeling? There are different use cases and requirements that we would need to think about from a business perspective. I work in business myself, so this is kind of the example. But of course, if you work in research or a nonprofit, this also applies. Depending on the outcome that you're interested in, we will choose a different type of model that would be appropriate for that outcome. While, for example, deep learning and reinforcement learning sounds really exciting, these types of models are very computationally expensive, and they are not necessarily the best models for every problem because they do take a lot of time and effort to be built, and they do take a lot of resources to run. And actually, we can solve a lot of problems with just simple machine learning models in business and again, in life. So choosing the machine learning model really begins with a good understanding of the problem that you're facing. So we should always start by thinking, what is the decision that we want the model to make? What is the outcome that we're looking for from the model? And then we can look at a whole bunch of different options, both in supervised learning and in unsupervised approaches. We have many different models that we can choose from. We typically will choose the model, several of them. We might test a bunch of different models and see how well they work for a particular problem. And then we'll select the model that we feel is most appropriate for a particular problem. But generally, supervised learning should be used when we already know the output that we're looking for, and we already have an idea of the decision factors that influence the output. Unsupervised learning, on the other hand, is really useful when we don't really know the output that we're looking for and we would like some inspiration from the data. So a good example of this would be things like customer segmentation. And let's go to the next slide. Now, machine learning and data science. Data science is a very broad field that encompasses a lot of different components, and machine learning is certainly a part of that. But beyond machine learning, data science also includes experimentation. It includes analysis. It includes experimentation. It includes statistical deep dives and analysis, right? So trying to identify relationships between different fields. So machine learning today is a core component of data science. In this particular program, we try to teach you the various components of data science, including how to analyze data using statistical techniques, how to use statistical models to answer the question of why something happened. We also cover experimentation and how to learn about cause and effect between different factors. And then, of course, we get into machine learning, which then comes into how do we automate decision-making at scale. And let's go to the next slide. Perfect. So we're going to jump to a quick demo of how to build a machine learning model with Python. Don't be alarmed by this if you've never worked with Python before. One of the benefits of Python is that it's a much easier language to learn than some of the other programming languages out there. When we use Python for data science, we are, not looking to build software, so you don't need to be a software engineer or anything like that. We're using the language in the context of being able to conduct analysis. So I want to do this quick demo to show you really what you can expect, not only to learn from the course, but also why Python is really favorable for machine learning. As a quick hint, it's because it makes it very easy to build and deploy some machine learning models. So I will take over the screen share. And, feel free again to post in the chat if you have any questions. But I do want to confirm that everybody can see my screen. Perfect. Okay, so what I have open right now is a Jupyter Notebook. And Jupyter Notebook is the primary mechanism that we're going to be using in the course to write Python code. This is called an integrated development environment. And every single programming language will have an integrated development environment that you can use. In this case, we're using Jupyter Notebooks because they allow us to build code iteratively. So what that means is that we can build our code in chunks before we actually deploy a production grade machine learning model. So don't worry about what those terms mean now. In the big data course, we'll cover terms like putting a model into production and model deployment and some of these other topics. Now, the first thing that we typically do when we start a machine learning project is we import the necessary libraries. So a few libraries that you can expect to see in the data science program are NumPy, which stands for numerical Python, Pandas, which is Pandas, and this is our data exploration library, Matplotlib, which is a visualization library that allows you to create charts and graphs, so visualizations, Seaborn, which is also a visualization library, and scikit-learn, which is the machine learning library that typically houses most of the general machine learning models that we might use in data science. So we're going to import a few modules from scikit-learn. The first thing we're going to do is import our data set. So for this particular exercise, we're going to be using a wine data set. Now, if you are a wine drinker, that's good. If you're not a wine drinker, then to give you a little bit of context, that's also good. But to give you a little bit of context, the the wine data set is about wine quality. So it has a bunch of different information about the quality of wine. And so the idea here is that we can predict the quality of wine based on some other information or stats we have about the different wines. The other piece that we're going to import here is something called train test split. So this is a function that allows us to train our models and then test how well the models would perform in the real world before we deploy them. We're going to import the standard scaler. So this is a function that allows us to scale our data before we actually deploy it into a model. And then we're going to import a couple of different models that we're going to try. So from linear model, we're going to import the logistic regression. So you may have heard of this in the past if you've taken a stats course. And from our neighborhood models, we're going to import k-neighbors classifier. So this is a different type of machine learning model that is a distance-based model rather than a probabilistic model. So again, in the machine learning course, we'll cover quite a bit about the difference between probabilistic versus geometric models and the pros and cons. But these two examples, they're examples of classification models. So they allow us to predict categories of different things. Now, the final thing that we're going to import here is our assessment mechanism. So for this one, we're going to import the accuracy score. And the accuracy score is a simple measure that allows us to measure how accurate a prediction is. So it gives us an overall sense of how good is the model that we're building in predicting an output. And if we have a really good model, then we're going to be able to, oh, I think I spelled something wrong here. Neighbors classifier. Oh, sorry, I misspelled this one here. There we go. Minor issue. But the accuracy score helps us learn overall how good the model is at predicting the particular outcome that we're interested in. So the first step to any data science model, or the second step, once we've imported our libraries that we're going to be using, is to load the data. Now, there's lots of different data sources. This particular data set is available in the in scikit-learn library, so we can just import it directly from there. But at your company, you may have a SQL database, you may have a data lake that holds a bunch of data, so you may be able to pull data from a whole bunch of different array of sources, depending on the particular problem that you're trying to solve. So we're going to use a function called load wine in this case to actually load our data set. And to give you a quick sense of what the data actually looks like, this is probably going to be a little bit messy here, but basically you're going to have a whole bunch of different information. So in here, sorry, give me 1 second. This is basically 2 arrays of data that allow us to see what the data looks like. So you can see in the first array, we have a whole bunch of different information about the wine. So actually, let me clean this up a little bit so that it's easier to see. So let me pull out the data, and then let me add some feature names. And then let me pull out the target variable here. So hopefully this will make it a little bit easier to see. So let's look at it like this. So we have a bunch of different data here. Now this is information about different types of wines. Again, the intent of this particular model is, can we predict the quality of the wine, or can we make a prediction about how good a wine is going to be based on information about that particular wine? So the type of information we have available is the alcohol level of the wine, the malic acid, the ash, the alkalinity of ash, magnesium levels, the phenols, flavonoids, non-flavonoid phenols. I don't even know what some of these words mean, to be honest. But again, if you're familiar with wines, perhaps you do. But otherwise, you can do a bit of research so that you can see exactly what each variable means. And after this, let's pull out the predicted variable, or the target variable. So for each entry here, we have a rating of the wine. So for each entry here, we have a 1, 0, 1, or 2 for the quality of the wine that we have, 2 being the highest or a high level category, 0 being a low level category, for example. So this first wine, this is actual data. So people went out into the world, they recorded some information about wine, and then they gave it a rating here at the bottom. Okay. Now, the third step after we load our data is always to do a little bit of exploratory analysis. Now, exploratory analysis means that we're trying to get a general understanding of what the data might look like. A really easy way to explore data is to first use a function called describe, which will give us a summary of statistics, so summary statistics about the data. So based on this particular data set, for example, we can see that the median percentage of alcohol of the wines we have is 13.05. The minimum is 11.03, and the maximum is 14.83. So we have some range of alcohol in the wine. Let's look at another variable. Let's say this magnesium variable. The median magnesium value is 98, and we go as low as 70 and as high as 162. So we do have, again, quite a range of different wines that are available in our data set. The second way that we can visualize our data is by looking at a pair plot. So a pair plot is a fantastic function in our scikit-learn library that allows us to very quickly plot a whole bunch of scatter plots so that we can understand visually what might be the relationships between data. So let's name this column on the Y here, the quality. And basically what I'm doing right now is I'm just combining my 2 different tables that I have here of data. And I'm going to create a quick sorry, this is a capital Y, and I'm going to create a, what do we do? Oh, sorry, didn't need to close this. There we go. I'm missing one more bracket. And then I'm going to create a whole bunch of different pair plots or scatter plots that allow me to see what the relationship is between the quality and the individual independent variables. So this is a quick assessment of relationship that can help inform my modeling approach. So we'll give it a minute. This is a pretty heavy function, so it'll take a quick minute to load here. And I'm just quickly checking the messages. Thank you, Larry, for answering them all. And we're almost done with our plot. Is the Y array just a group of classifications? Yes, the Y is basically the classifications that correspond to each row. So we can see here that row 0, the output or the quality output for this particular row is 0, so low quality. Row 4, for example, that's the 4th output, which is also a 0. So the Y variable corresponds to the X variables. All right, so we've got the function here. Good question, Roland. The IDEs will typically not tell us how long a function will take, but it really depends on your computer and the available resources. Now, this is kind of a big data set in the sense that it's got a lot of different columns, which is why this particular function takes a long time. For most other functions, they should be fairly quick with a normal computer. Okay. So this is an example of what the pair plot might look like. So for example, if I zoom in here, I can compare the relationship between alcohol and quality. So in this plot, I can see that the higher alcohol, so the range where we have the higher alcohol, generally has a low quality, and the high quality rated wines, they have actually a range of alcohol in them. So probably alcohol by itself is not a great predictor of whether the wine is going to be good quality or bad quality. Now, in another example, let's maybe take a look here where we have a little bit more distinction. So the high quality wines typically have low flavonoids. I don't really know what flavonoids are, but high quality wines typically have a lower range of flavonoids, whereas medium quality have a bigger range kind of in the middle, and low quality wines have a higher range of flavonoids. So I can kind of start to put together a story here that probably this variable, like the flavonoids, is going to be a good predictor on whether or not the wine is going to be a decent quality wine or not. And another example, let's maybe look at this variable here. So I don't really know what this means, but this is actually, let's look at this one's a little bit easier. The hue. So the hue of the wine, low quality or somewhere in the middle. Higher quality wines tend to have lower values for hue, and then medium quality wines tend to have this sort of middle range of the hue. So the scatter plot in the exploratory analysis, the main objective is for us to be able to try to start to build some hypotheses. So a hypothesis is basically an initial idea or an initial thought around what might be the relationships between the inputs and the outputs. Now, we could also create a whole bunch of different scatter plots by themselves, but again, the power of this function here is that we're able to very quickly plot all the scatter plots available at once. So this is why we're able to do this. This function allows us to plot everything at once so that we don't have to build a whole bunch of different separate scatter plots. Okay. So now that we have some idea about the relationship between the inputs and the outputs, the next step is for us to prepare our data for modeling. So what we're going to do in this step is we're first going to split our data into training and testing data. Now, the reason we do this is because let's say that we own a wine business. So we're a producer of wine, and we really want to be able to predict the quality of the wine before we start bottling it and selling it. So maybe we're doing we're trying different techniques. We're trying to predict the quality of the wine. Now, we need a model that's going to be reliable. So how do we know that a machine learning model is reliable? Well, we can't just simply teach the model to make decisions and then put it out into the world, right? We need to be able to assess how well did we teach the model to make decisions. So the reason we split the data into training and testing data is because for all of these different observations that I have here, I already know the outcome. I already know whether the wine was good or bad. Now, what I need to know is if the model is able to predict accurately what the quality of the wine is. So I'm going to use part of the data set. I have about 170 observations. I'm going to use part of the data set to teach the model how to make decisions. And I'm going to reserve a small portion of the data set to then have the model create an output. And I'm going to compare it to the actual output to see how good the model predicted. So how good is the model at predicting an output with accuracy? So that's the reason why we split data in training and testing data. Now, this is pretty simple with Python because we simply use a function called train test split. We will take the X variable, we'll take the Y variable, we'll determine how much of the data set we want to reserve for testing. So in this case, I'm reserving about 30% of the data set for testing. And then I'm going to set a random state here. This is just a good practice so that just by accident, if I run this function again, I'll make sure that the same data points are included in my training and testing. And then I'm going to scale my data. So what that means is that I'm going to make all the data between the same range. So right now I have some data points that are between 0 and 10, some are between 40 and 50. So they're all at different scales. But machine learning is a little bit sensitive to scaling to unscaled data. So it's a good practice to always scale your data before you deploy a model. So I'm going to make a new variable here, xtrain scaled, scalar.fit transform, xtrain. And again, you're going to learn all these functions in the machine learning course. Xtest scaled, scalar.transform, xtest. And now we've got all our data ready, and now we're pretty much ready to use our models. So building the models is basically 2 lines of code. It's very simple. So let's build our logistic regression first. Logistic regression. We're going to set a max number of iterations, which is 1,000. This is an optimization parameter. And then we're going to fit our logistic regression with the training data. And that's it. The model is built. So very simple. And we're going to do the same thing with the K-neighbors model. Classifier. We're going to select 5 neighbors for now. And again, we're just going to fit our model. So this is the process. This is the line of code which actually trains the model itself. There we go. And we're done. So we now have 2 models that we have trained on the data set. So now the next step is let's see how good these models are at actually making predictions. So we're going to predict some data. We're going to use our testing data set. We're going to predict some values. So we're going to predict some measurements of quality. And remember that we already have the true quality metrics. So we already have the true quality measures from our original data set. So after the model predicts, we're going to compare how many of those predictions did the model capture correctly. And hopefully the more predictions it's captured correctly, the better. So we're going to make some predictions here for the logistic regression first. We're going to take our logistic regression model. We're going to make some predictions. And we're going to take our KNN model. And we're going to make some predictions here. Okay. So here's a quick example of the output. So remember, we reserved about 30% of our data set. So here's the predictions of each of the models. And then here is the actual outputs. So we can see that for the first observation in the testing data set, the logistic regression predicted that the output would be a 0. The KNN model also predicted the output would be a 0, and the actual quality rating was also a 0. So both of the models got this first one correct. The next one, the logistic regression, also predicted a 0. So did KNN, and the actual was a 0. So this one was also correct. The third scenario, let's look at a different case here. Let's look at this middle one. So in this example here, you can see that for this observation, the logistic regression predicted the output to be a 1. The KNN model predicted the output to be a 0, but the actual output was a 1. So in this case, the KNN model made a mistake. Okay, and then quickly, let me see if there's any other major mistakes here, although we will check in a minute. Here's another example of a mistake. In this one, the logistic regression predicted that the output should be a 1. The KNN predicted it should be a 2, and the actual output was a 1. So again, the KNN model made a mistake here. So different models use different approaches in making predictions. And sometimes different models might be more or less appropriate for a particular data set. And this is why we have access to many different types of models, because we can build different types of models. We can see how well they work on a particular data set. And then we can make a decision about which model works the best for a particular data set. Now, to summarize the results, we're going to use an accuracy score measure. So we're going to use the accuracy score function, and we're going to compare first for the logistic regression predictions to the test data set. So we can see that the logistic regression was 98% accurate. So it probably only got one of the entries wrong. And let's look at the KNN prediction versus the testing data set. We can see that the KNN model was only 96% accurate. So it made 2 mistakes instead of 1, which we both just looked at. So now, if we were in the decision-making position of deciding which model to deploy to help us make predictions for our wine quality, in this case, the obvious choice is going to be the logistic regression, because it does have a higher accuracy score. Okay, does that make sense? Hopefully that gives you a little bit of insight into how we will build machine learning models. Of course, there's a lot more to this. So in the real world, we would do quite a bit more analysis. There's a lot more functions that you have access to and different techniques that we would use for machine learning models. But this is a fairly basic example of how we can build a machine learning model with Python. So let me have a look at some of the questions here that I see posted. How do you select the size of the testing data set? Well, that's a good question. There's a general rule of thumb that we will typically select 20% or 30% of the data to test with. So we'll typically train the model on 70 to 80% of the data, and we'll reserve 20 to 30% for testing. And I see Larry actually already answered that. Thank you. And then the second question was around what is random state? Random state is a parameter that a lot of different functions have in scikit-learn, which allows the computer to select the same observations every single time. So everybody's computer has a randomization counter. So when you so the train test function will randomly select observations to use for training and randomly select observations to use for testing. Now, let's say that I went back into my function here and I ran this many times. I just executed the cell multiple times. If I don't have this random state parameter, the function that I execute is going to select different observations every single time I run it. So sometimes if I want to have consistency and integrity in my training and testing process, I set the random state so that the function will select the same observations every single time. Okay. Can we also use machine learning to find an appropriate model instead? Good question, David, but not really. So we can run, ideally we have to tailor each model to the data or tailor the data to the model. And so that requires a lot of understanding on the data itself. It requires understanding on the appropriate treatment to the data. So we do have to go through the process of finding which model works best for the given data set and how can we transform the data to make it appropriate for a particular model. We could probably build a system that can try a whole bunch of different things. So of course you can automate anything, but it does require some human transformation in the process. And Kevin, yes, I believe this code will be sent out. How do we access these models? Good question, Hussam. So the scikit-learn library in Python gives you access to all of the models that we typically use for machine learning. Are we going to learn how the models work in detail? Yes, Nam. So in the machine learning course, we go through each model. We have a separate session for each model, and we do go through them and how they work, how they make decisions, the math behind them, and of course, how to implement them in Python. Is knowledge of Python a prerequisite for the course? No, so we do start right at the beginning. Now, if you've never programmed before and you don't have a programming background at all, I do recommend spending more time up front. So we do have a recommended textbook. We do have recommended exercises that we cover in the course. So if you don't have a programming background, you will need to spend a little bit more time up front just to, really learn the concept and be able to use Python. But you don't need to necessarily be an expert before you take the course. Okay. Is there a way to convert the model into a math equation containing the data sets? So not really here. Yes, actually you can. So you can pull out the coefficients, for example, you can pull out the intercept and the coefficients, and you can write your own math equation, but the notebook itself will not produce a LaTeX written equation for you. Yes, the value of the random state doesn't really matter. If you and another person on the computer or another person on another computer want the same observations, then you should have the same value for the random state. Is there a recommended data size to be able to run a prediction? Ideally, when you have more data points available for you, then that's better. So ideally for most machine learning models, you do want to have, in the thousands of data points. This is a very simple data set for beginners that you can start to learn some of the concepts. But in the real world, we do want very large data sets with 10,000 observations or so. Okay. And that's right, Joel. So the benefit of Python programming is that we do have abstracted functions so that the Python will do all of the work for you, and you don't have to build a lot of these things from scratch. But I do need to wrap up the questions. So if you do have further questions, feel free to send them in, and then the WatSPEED team will ensure that you have all of the answers. And I think I now will hand it over back to Larry and the WatSPEED team. Thank you all.
And I'm back. After a little argument with Zoom as usual. Okay, so let me tell you a little bit about the program and a little bit about what it takes to move to a career in data science. We've had about 1,200 people now through the certificate program. It's an online set of courses, 4 courses. And we teach a wide variety of skills that are required to be successful in data science. What does a data scientist need in order to do data science? Well, it's not just the math and stats and machine learning aspects of this, but a data scientist is a rounded person that typically has some experience, knowledge, or background in many of the bubbles that you see in the diagram here. Typically, domain knowledge, either in the particular business the person works in, or if it's a more scientific discipline, in the science behind it. Depending on your role in data science, whether you're primarily focusing on models or are involved in actually deploying models and building the infrastructure to run them, software engineering and data engineering skills may be helpful. Experience with storytelling and visualization. It's one thing to be able to come up with a good data analysis. It's a completely different thing to be able to express that in a way and communicate it in a fashion that makes it easy to consume for people to understand and to actually influence decision making. There's a whole set of skills around that and techniques for building graphs and diagrams and showing data in a way that is naturally easy for people, given the way that our minds work and the way our eyes and ears work, to make it easy to pull the important messages out of that data. And we talk about those sorts of things. So quite a wide variety of skills involved. Next slide, please. So our program, it's been running for quite a few years now. It consists of 4 courses. As mentioned, we recommend taking them in order. And the first is Foundations of Data Science, followed by Statistics for Data Science. Then the Machine Learning course that goes deep into the algorithms that Delina was talking about today. And then the fourth course, which is a little bit different in flavor, which is more about how you operationalize machine learning models, particularly in the world of big data. If you need to scale up to very large internet scale applications of these models, how do you do that? Next slide. Some of our instructors, in fact, are people who came through the program themselves with a background already in statistics or the sciences, and are now teaching in the program. We have a very wide variety of kinds of people that are in the program, and it's kind of interesting to teach from that perspective, because we have people on the one hand who have done no programming whatsoever before, and perhaps have only sort of kind of an introductory prior experience with math and stats, to people who are PhDs in the hard sciences. Often there are people who are interested in getting into a career in data science and are retreading, if you like. And also we have people who are interested in either applying it in their business jobs, or looking for a better job with better pay, or are just interested in learning more about it. So these are some of our instructors. The thing that's different about our instructors versus some other programs that are out there is that our instructors are all working professionals. It's not a purely academic kind of program. It's roll up your sleeves, let's do this together, lots of hands-on experience with tools all the way through the program, so that when you come out the other end, you're ready to hit the ground running. So as you can see, wide variety of very strong instructors. Next slide. So what exactly would you learn if you took this program? Python, of course. Introduction to Pandas, which is the premier Python-based library for machine learning and data analysis. It starts out with an introduction. By the end of the program, you can make it dance. Visualization, we cover SQL or SQL database queries. In the second course, those are things that are covered in the first course. Second course is probability, inference. So how do you make decisions? How do you cast hypotheses and then test those hypotheses? Not only kind of the traditional, if you took some statistics a few years ago, and you might have taken some inference, the game has changed completely in the last couple of years with the introduction of causal inference, which in doing the data analysis, you take into account not just the correlations between variables, but what are the actual causal relationships between them, what actually drives what other changes. Like when one thing varies, what does it actually cause to vary in other places? And in fact, this kind of thinking about inference has demonstrated that a lot of the statistical analysis that was done in the 20th century is actually potentially wrong, like outright incorrect. So it's a very new, very powerful technique. Regression and classification, of course. And then into the third course, machine learning course. So feature selection. So how do you decide out of a big data set that you have with maybe 100 columns in it, which ones are actually the ones that you're going to include in your model? If you include sort of other data in your model, which it isn't actually predictive, typically you can expect a degradation in the quality of the model of about 5% for every additional data item that you include in your data set, which is just noise, not predictive. So dimensionality reduction, if you have this data set with all these columns, how do you reduce it down to just the columns that are actually going to be useful? We talk about neural nets, so preparation for moving on into artificial intelligence later on, if that's a direction that you want to go. So we cover the basics of how deep neural nets work. Next slide. The fourth course, so that's the data engineering one. Roll up your sleeves again, hands-on with Spark and with MongoDB and other big data technologies. We talk about how you put all the big data pieces together into a full pipeline streaming application using these kinds of techniques. We talk about distributed databases. It turns out that when you move from a single database, like a relational database on one server, to data which is distributed across many servers, all kinds of additional issues come up that need to be properly dealt with. We talk about machine learning operations. So how do you work with the team to make sure that if you're deploying machine learning model, it's deployed properly, it's monitored properly, and is continually improved on over time. And we also talk about the cloud offerings that are out there for supporting machine learning. Next slide. So the program is 8 to 12 hours per week of work. I think some of the people who take these courses would say it's actually a bit more than that. It's a big topic, and there's a lot to learn. And people that get into it, they get excited, and they're happy to spend the time that it takes to really get their heads around it. There are readings. The material is all provided in the form of Jupyter notebooks, similar to what you saw with Delina a little while ago. So it's not only the theory behind this, but also tons of code examples you can run yourself right in the notebook and tweak them and experiment with them and play with them. We have weekly webinars, so the instructors will host once a week a hour and a half, and the intention of that is to provide a little bit of additional color around the material that's in the notebooks. So it's not a pure lecture format. Typically, there's a little bit of hitting in the highlights of some of the things that were in the week's studies. But the time is also your opportunity to ask questions and also to talk about the assignments and get to know the instructors and your classmates. We have a discussion board. It's a great way to ask questions. And it's the nice thing about it is that the instructors every day will go in and see what questions are there and answer them. Not only that, but also the other people in the program may have run into the same problem and already figured out a solution and can post a solution as well. So 3 or 4 assignments per course. There's no exams in the program. It's all based on project work. Next slide. So let's look at some of the questions.
Larry, before you take a look at the questions, I just wanted to point out that because we've reached the Q&A segment, I would like to invite anybody, if you'd like to come off mute and ask your questions. Now is your time, and I'll just give that a minute. Okay, because we're short on time, we can take a look at the chat, Larry. We do have a quick question here that says, do we get a certificate of completion? That is correct. You will get a certificate for each course that you complete in the data science program, and you will also get a certificate for the entire program. So that would be 4 certificates if you complete all 4 courses, and then a full data science certificate as well. Are there any financial aid options for this certificate? No, unfortunately, because this is a collaborative program with the University of Toronto, we cannot offer any financial aid for any of our courses within that program. Larry, I have a question here for you in the Q&A section of Zoom. It says, having completed the data science certificate, what is the next logical progression? AI courses or anything else you can suggest?
Yeah, so WatSPEED has a variety of AI courses available. So does the School of Continuing Studies at University of Toronto has a certificate program which follows on in AI. The machine learning course is common to this program and the U of T AI certificate program. So if you do ML here, and take 2 additional courses with SCS at Toronto, you can get in AI. We're also working on potentially doing a follow-on certificate in advanced data science that will follow on to this program. It's just something that's under consideration at this point, so absolutely no promises, but it's something that we're looking at.
Thank you, Larry. We do have another question that I can take a shot at. What are the days and times for the live sessions? For each course, there's a different time that we have. So feel free to email us at watspeed@uwaterloo.ca, and I'd be happy to share that information with you. Just because we're short in time, I won't be able to get into the details of that. Can we use the data science certificate to apply for an undergrad degree in data science?
Not directly. This is non-credit education, so these courses don't count as courses towards a degree. But having said that, it does strengthen your argument for admission into a degree program.
Wonderful. Thank you, Larry.
We've had many people who've done this program and then gone into a degree program, often a master's of some kind in either data science or analytics. Although a Master of Analytics covers pretty much the same material that we do.
We have another great question here. It says, we could learn all of these courses on Coursera, edX, or other platforms. Can you tell me what's the advantage with this course?
Well, a couple of advantages. You get to interact with the instructor and with other people in the program, and as a result, you build a network at the same time, which is something that you don't get from Coursera. And you also, at the end of it, have a certificate from the 2 most recognized names in computer science and related disciplines in Canada, the University of Waterloo and the University of Toronto.
Wonderful. Thank you. One last question that we can get to. How many courses can we do simultaneously? Melanie did answer that question, but just a quick note. We do recommend taking just one course at a time. Like Larry mentioned previously, there is going to be a whole lot of work that goes into one course, and it is 12 weeks long for each course. So we do recommend taking first the Foundations of Data Science course, because that's the prerequisite for all the other courses, and then you can move forward in the same order that we've mentioned it on our website.
Yeah, I should add that it is open enrollment though. So if your intention is not to do the certificate, but just to cherry pick a particular course, you can do that. But there are relationships between the courses that assume that you do have the understanding of the previous ones. So you're kind of doing it at your own risk if you jump into a course in the middle.
Wonderful. Thank you, Larry. We also have another important question that says, if having an extensive knowledge of other programming languages, including Python and Experience, but not having the prerequisite of the Foundations of Data Science and Statistics course, is it possible to enroll in the machine learning course directly?
Yeah, so that's essentially the same. Yes, yes, you can, but you better be sure that you are strong in the foundations and stats before you do, because we assume that you're solid in those areas.
Absolutely. Thank you, Larry.
Good morning. Thank you for contacting the Brock Services. My name is Nam.
Hi.
Nam, did you have a question, or feel free to come off mute if you would like. We just have about a minute remaining, so any final questions are welcome. Okay, I think we're good.
Hi.
Larry, thank you so much for, sorry, was that somebody?
Hi, I have a question.
Yeah, go for it.
So what is the total cost of this program? And also after this program, would this allows me to go for a master's degree if I attach it to my bachelor degree?
Well, the total cost is on the order of around $4,000, in the $4,000 to $5,000 range, for all, to complete the entire certificate. And it would strengthen your argument for doing a related master's, but it's not a guarantee, and it's not necessarily something, it's not something you would necessarily need in order to do a master's if your bachelor's if your undergrad is already in this area. Like, are you asking the question because you have an undergrad that's in a completely unrelated area and you'd like to move into a master's in this area, or?
No, I'm actually asking this question because I have a bachelor degree in electronics engineering and I'm interested in machine learning. However, I'm also offered a master degree from University of Texas in artificial intelligence. So, but my friends, they told me you don't need a master's degree. They just like a boot camp is enough to strengthen your application or your portfolio.
Well, I mean, there are a lot of reasons that a person might choose to do a master's versus doing a program like this, and that's kind of a big topic in and of itself. I would say think carefully about it. It depends on where you want to go ultimately with it. Like yes, you don't require a master's, but there are some employers out there that might require a master's for specific jobs.
Thank you, Larry. I will just answer one last question before we close off the session today. We did receive a question saying that I am in Pakistan and you would like to have the live session timings. So again, feel free to email us and I can give that to you. If you're in any other time zone, we will also record the session, so they will be available for you to view at any time of the day. So with that, we have come to the end of our session. Thank you so much for joining us today. Thank you to Larry and Delina for leading us through this. And just a quick reminder that the start date for our data science courses is beginning January 29th. I will put the link down in the chat below. And if you have any questions, again, feel free to email us or give us a call at our office. And thank you so much for joining. We hope you have a great day.